as Serverless Cloud Networking Architecture for Scalable Real-Time Applications. My project supervisor is Madam Roziyani Binti Rawi. The objective of this project is to solve two major problems faced by small and medium-sized construction firms, especially my case study client Minahil Fatima General Maintenance Contracting. The first problem is high network latency caused by routing data to centralized US servers rather than the server nearby the enterprise. The second is massive financial waste and loss caused by traditional virtual machines that run 24 hours a day, even when the construction site is closed. My project solved this by building a custom event-driven edge cloud architecture. How does that work is in the construction industry, remote teams need to sync daily logs and heavy blueprints in real time. However, small, medium enterprises often get priced out of high-end enterprise software. If they rent standard cloud servers such as Firebase, AWS, they pay for idle time on nights and weekends. To fix this, I designed a completely serverless infrastructure. The system uses a mobile front end on AWS CloudFront, which provides a lower latency route to the API gateway nearby to the nearest network node. For example, in Malaysia, the nearest network node would be Singapore. The nearest network node for Canada would be USA, so and so forth. So when a field worker uploads a file, when a field worker or a supervisor uses a tablet to upload the file to the cloud front, the traffic is handled by Amazon's API, which triggers an AWS Lambda function. The Lambda runs the backend code instantly and statelessly. Heavy files like PDF go straight into Amazon S3 bucket, while lightweight metadata is stored in Amazon DynamoDB for rapid querying. Because this is serverless, the compute cost drops to exactly zero when the system is not actively being used. Only when the AWS Lambda node functions or logic is triggered, that's only when the costs are provided. My demo would be, this is my user interface. Any worker or a site plan wouldn't need to use any form of any software developer or SDK files. It's user friendly, as I have provided the solutions that are real-time field reporting. So the supervisors or it's RBAC mode. So not everyone can submit all logs, upload, or rename files or delete data. I've also provided S3 asset control, which means I store the drawings, RFI infection photos in project scope object storage rather than just the DynamoDB, which can be hard for querying proper data. The infrastructure cost optimization, which is zero idle compute. If it's not being used, you don't have to pay for it. Moving on to the pricing, in the starters, we have $0 ringgit a month. For the pro contractor, it would be 199 ringgit a month. They won't have to pay for anything after that. It's pay as you go. They would provide 100 GB worth of S3 compatible storage. It also has a role-based access control so that not everyone inside the company or the enterprise is able to edit any form of data, so and so forth. So moving on to the developer side, where the developer can edit or install my Cloud Sync on via npm cdn, and they could initialize a client using their own project ID provided in their API key. The full API reference can also be viewed from here, which would be quite lengthy to proper understanding how it would work. There are other devices as well. For example, there is, imagine a construction site is in a remote area and they could use GPS coordinated tablets for proper synchronization and no need of internet. The resources that I've provided is a case study on on my client currently that the project is built on, the white papers of the centralized cloud, and as well as the serverless economics in clinical constructions. There are video tutorials as well, the live demonstration, upload and role-based access mode as well as deploying the Edge SDK on RUG tablets, as well as the webhook setups are the web video tutorials provided. So this is the shout out to the featured client, Minail Fatima General Maintenance Contracting. They are a regional leader in civil engineering and maintenance. They are digitizing field operation through serverless edge infrastructure. Let us look at the live demonstration. I have already signed in. For purposes, I would show you how to sign in. Basically, I'll go with admin. And for this one, I'll use admin for the sign in. As you can see, I am able to upload the files, refresh the file, choose the file, and upload the file basically on the files itself. Next, I would also open a login using the foreman or an engineer. As you can see, I'm unable to upload the files, refresh the files, or choose a file to upload in the data, as well as it's failed to fetch the files. I'm unable to see the files as of now because the admin or the engineer hasn't uploaded a file. I will be able to view it, but I won't be able to rename it, delete it, or make any changes to that file specifically. So security and data integrity are critical for construction projects. I implemented this role-based access control on the application level. Uh, right now, I'm logging in using the foreman as well as the admin role, but the upload and delete functions are strictly locked for foreman, as we can notice. I have already ensured that the interface dynamically updates to grant full control to admin and required colleagues. It pushes the metadata directly to the AWS S3 bucket. So I'll upload some files using the admin. I'll upload response playbook for the site plan. I'll be uploading this file. If you notice, I have already uploaded the file, and the file could also be viewed here. But if you notice, for the admin, I'm able to view it, download it, rename it, and delete it. But for the foreman, I am unable to download. I'm able to download it, but I'm unable to rename it and delete it. I'm able to view it and I'm able to download it. So if I open two separate sessions side by side and I send a message in the team chat from the first window to the second one, for example, um, kindly download the file, and I go to foreman, you could see that the admin has texted that kindly download the file at this minute and this hour. The system also runs a 50-second heartbeat to track active devices on the sites and making them offline if they drop connection for more than 60 seconds. So this is the client side of the team chat and everything that's engineered. Basically, I engineered a cross-type synchronization system using local storage event listeners. Moving on to validate the success of this architecture would be, I'll open next one. So here, if we see that my console hostings, so these are the statical hosting test and the result and analysis. To validate the success of this architecture, I built a dedicated benchmark module to test latency. That test had run for exactly 1,000 hours, 40 days that test ran for. While testing the round trip time, routing request to standard US central cloud server result in an average latency of 240 milliseconds using Firebase. And I uploaded an HTML static hosting on both my edge cloud as well as the Firebase edge cloud. For Firebase, I got the latency as 240 milliseconds, and for mine was lower than 50 milliseconds, around 42. During the test, I got a constant 42. And if I see the cost model for Firebase, I noticed that during the benchmark testing, I would have to waste $52 just staying online up in while deploying the HTML file. My serverless architecture incurred exactly $0 in compute cost during that same idle period, eliminating 100% of infrastructure cost and eliminating 82% reduction in network delay, proving that edge routing provides a vastly superior experience for local field workers. I'll be running the benchmark test and SDK demo. Uh, this is basically the to test the latency and cost against traditional centralized models. I have initialized using Firebase SDK as well as my personal custom SDK on the Edge Cloud. So if we see here, we have already initialized a Firebase connection on US Central 1 for Firebase. And the Firebase ping response was 200 milliseconds from Malaysia, which is high latency due to centralized routing. Next, I initialized the MFGMC, Min Fatima General Maintenance Contracting Edge Cloud connection on the SDK, which is AP Southeast 1, which is Singapore. I got a ping response of 42 milliseconds, low latency via Edge network. The calculation cost for 1,000 idle hours was $52 for Firebase, or a standard virtual machine cost such as Firebase, AWS, Alibaba Cloud, so and so forth. And for MFGMC serverless cloud, since I haven't used anything for or during those idle hours, it was $0. And after running a test, it would give me a brief conclusion how of the edge distributed serverless architecture reduced latency by 82% and eliminates 100% of the idle infrastructure cost, as I said earlier. In conclusion, this project has successfully democratized advanced cloud networking for small mid to medium enterprises. By shifting to a distributed event-driven model, construction companies can achieve real-time synchronization, enterprise-grade security, and zero-waste unit economics. For future enhancement, the system can be upgraded to utilize AWS pre-signed URLs for even stricter upload security. Additionally, integrating service workers would allow site foremen to log data completely offline using the RUG tablets, and syncing automatically once they return to an area with internet or GPS coverage. Thank you for your time and for reviewing my final year project.